Okay, for the question number 1, there's the function kx equals 5 minus 2px plus py, and ky equals 6 plus px minus py. And then determine the 4 partial marginal moments and the relationship between the two products. For the questions A, find dou qx, dou py, dou qy, dou px, dou qx, dou qx, dou px, and dou qy, dou py. The derivative kx of py is 1, and the derivative of ky of px is 1. The derivative of kx of px is minus 2, and the derivative of ky and the derivative qy of py is minus 1. Oops. For the question B, dou kx, dou py, and dou qy, dou px is positive because greater than 0. So the relationship between the two products is competitive. For dou px, dou px, and dou qy per dou py is negative or less than 0. So the relationship between the two products is complementary.
The next question, number 8. Z equal x the power of minus 2xy plus 2y the power of 2 minus 2x plus 2y plus 1. So the first find derivative of x. The z divided to x equal 2x minus 2y minus 2 equal 0. Find derivative C of B. The z equation. Minus 2x plus 4y equal min 2 2x plus 4y equal min 2 min x plus 4y equal minus 1. So minus x plus minus x means 2y equal 1. The next elimination 1 and 2, x minus 3 equal 1, x minus 2y equal 1, x minus y minus x minus 2y equal 1 minus 1. Y plus 2y minus y plus minus plus 2y equal 0. Y equal 0. Second derivative from 2. The power of 2c divided to x the power of 2 equal to the power of 2z divided to y the power of 2 equal 4 to the power of 2c divided to x to equal to. Next, determinant from function 2 equal the 2z divided to x the power of 2 the power of 2z divided to x to the power of 2z divided to x to z to y to the power of 2 determinan Q more than 0 and do the power of 2z divided do x the power of 2 then the critical minimum.
Next questions from Kanaia, page 93, number 2. Determine price and quantity that maximize profit and its maximum profits. So first we're gonna find the profit. Profit is TR minus TC. So there's no TR. We're going to search from TR is equal to PX times KX plus PY times KY minus TC. Don't forget to input the terms. Next, we're going to search for the first derivative. We rearrange it from the key x with no power 2 to key x py power of 2. first derivative of qx is 8 minus 2qx equal to qx and qx is 8 divided by 2 equal to 4. Next, the first derivative of qy is 10qy and minus 2qy. 2qy equals to 10 and qy is 10 divided by 2 equal 5. Next, we're searching for the px and py. Px is 12 minus qx and py is 15 minus qy. The qx is input from there to previous one, so the qy 12 minus 4 equals to 8 and 15 minus 5 equal to 10. Next, we're checking the second derivative of the profit. Using the qx do power of 2p to qx power of 2 equal to 8 is minus 2. So, because this is minus 2, is less than 0, as plus minus 2, that less than 0. So, because of this minus 2, this was the max score, of profit. The curve will be going down. So the maximum profit was in qx equal to 4, then qy equal to 5, px equal to 8, and py equal to 10. The profit max qy px py to the function of profit. Plus 10qy minus qx power of 2 minus qy power of 2. Then substitute. Times 4, 32 plus 50 minus 16 minus 25. 41. That's all for me. Thank you.
Yeah. So the next question, number 4, is a computer firm established the following total revenue and total cost function for computers. So this is the functions of TR and TC. TR is minus 0.2 the power of 2 plus 900t, and TC is 0.03 the power of 3 minus 0.2 divided of 2 plus 6,000. So this is the equation. The first question is find the corresponding marginal revenue and marginal cost function. The second question is use the result of part to find the quantity of computers corresponding to maximum profit. And the last question is what is the maximum profit? So the first we find the marginal cost MR. The first step we must to find the derivative from total revenue to TR divided the Q equal minus 0.4 Q plus 900. So the second is marginal cost MC to TC divided to Q. So the result is 0.09 Q power of 2 minus 0.4 Q. So this is the result question. First question. MR and marginal revenue and marginal cost. The second question is to find the quantity of computer corresponding to maximum profit. So the computers are quantity is the marginal revenue equal marginal cost. So the MR equal MC. Because we have been defined derivative from marginal revenue and marginal cost, so we put it in here. So this is because minus 0.4 and minus 0.4 is the same, so eliminate. get 900 equal 0.09 cube to the power of 2. So this is after this we put the other side. So 900 divided 0.09. So cube of 2 is 1/10,000. Because this cube the power of 2, we must to so the result is 100. Okay, so this is the result from the second question. 100. So the next is after we find the cube. After we find the cube, step is the last question is maximum profit. The formula is P max TR minus this. So this is the formula. The first step is we put it in Q and the derivative of marginal revenue. TR. We put it in Q. So the result is the second is DC years. So this is the result. After we find the maximum TR and DC, the last step is we must to find the maximum profit. The formula is TR minus DC. So TR minus. So the result is 8,000. So this is the step to find the equation from number 4. Okay, so this is the result. Thank you.
So for the last question, we have the question from Kalami book, the second book, page 94, number 24. And then the question is, if the utility function u equal 4xy minus y to the power of 2, and the budget function is 2x plus 5y equals 11, determine the value of x and y that maximize the utility function here. So for the first step we make the Lagrange function. Lagrange function is a combination between the main function, which is the utility function, and then the constraint function, which is here is the budget function. Alright, the second step is find the first partial derivative, because we have three variables here. Partial derivative. First derivative of this function. First one, we derive the x. And then we derive the y. And then we derive the lambda. And then don't forget to make them equals to 0. Sorry. And then here we got three equations. This is the first one, second, then third one. And then the third step is to find value of x, y, and lambda by elimination and substitution. So first we eliminate the first and second question. We eliminate the lambda here by using the first and second equation. We're going to make the lambda have 10 constanta. So the first equation we times with 5, and the second one times with 2. 25 minus 10. 10. And then 8x minus 4y minus 10 lambda. So here we got the fourth. Running out the ink here, and then we try to find x or y. You can either choose both of them. I think we're going to find the y first by the third and the fourth equation. We're trying to make this equation looks more tidy, looks more easier to calculate. So wait, let me write down this again. So this, we're going to move the minus 2x minus 5y into the left side. So it's going to be positive like this, right? And then we're going to make the x have the same constanta. So it's wait, no, yeah. Sorry, it should be plus. So 4y equals to minus 4d4. So we got the y is minus 11, right? And then we're trying to find the the x value by substitute the y into equation 3, this one. So we got here minus 55, but we move it to the right side, should be plus, and we got x value 33, right? Okay, and then after this we are trying to I'm going to move it by using the second equation we got here. We got the x 33 and the y minus 11. I'm going to use the calculator. It's gonna be plus, right? And then we're going to move the sorry, it's not 3, it's 5. Move the lambda to the right side. It's going to be plus, and then this one is, oh, it's minus. It's decimal. No, sorry. Yeah, right. And then Amelda for x, y, get x, y, x, y, x, y. So, but we're trying to find this value, the value of ux. I'm going to write down here. Ux, uxy, uyx, uyy, and then gx, gy. We can find this values by finding the second derivative. For the ux, we got 0 because there is no x right here. And then for uxy, xy, wait, x, what, 4, yeah, right, 4, and then the yx here, so yeah, x, y is 4, yx is also 4, and then for the uyy, it's -2, and then for the gx, it's, wait, it's -2 and -5 here. 0, -2, -4, 5, -2, -5, 0, 4, 4, -2. 2 times y times dx times ux, right? Sorry, uyx minus gy to the power of 2 times uxx minus gx to the power of 2 times uyy. And then we add this number to, so we substitute this number to this formula. -5 times -2 times 4, right? 4, and then minus 5 to the power of 2 times 0. Yeah, gonna be 0. And then -2 to the power of 2 times -2. It's gonna be 80 minus 0 minus, wait, 8 minus 8. The result is 72, which is greater than 0. It means that the utility means that the utility utility value is maximum. So we found x equals x33, y minus 11, around 30.8, and then we substitute these values into the utility function. I forgot the utility function. Oh, 4xy minus y to the power of 2. Right. 33 minus 4. Wait, it's minus. And then this one is so it's, yeah, plus, gotta be plus minus. Okay, wait, it's minus. The result is minus. Minus 1 minus 5,073. Okay, so yeah, the conclusion, we found x 33, y minus 11, which is the budget, right? The budget of x is 33, and the budget of y is minus 11. Budget can be negative. It's okay, unless we're talking about units or quantity of goods. It's impossible to be minus, right? But here we're talking about budget. It's minus, probably they have I don't know, like sponsorship, or what is it, account payable. It is possible. And yeah, we found x 33 and y 11 minus 11, and that maximize the utility function. The utility function, the utility just minus 1573.